In this part, we will be discussing about correcting the scientific notations. So, as we all know that in the scientific world, the measurements are usually written in the standard form, as you know, the scientific notation. But when we are playing with numbers, we can come across many scenarios where there is a numerical value which looks like it's written in scientific notation, but actually it's not. Usually we find those in those scenarios we will find that the values are written with tens power or the exponent of 10, and we just naturally assume that they are written in scientific notation, but in fact they are not. They are incorrectly written in scientific notations. So there's a very there are there are simple rules to check whether the numerical value is in fact written in scientific notation correctly or not. And to show it, let me just write some random value which is correctly in which is correctly written in scientific notation. So let's have a random value like we have, for example, let me write 1.23 times 10 exponent 10's power 4. So here we have a random scientific notation which is correctly written in scientific notation. And let me just change the color to have you understand a bit better. So let's try to split them up. Let's have two part of them. So one part is this, that is 1.23, and the second part is here is this, which is the exponent of 10. Let me draw it clear. Okay, good. um Now the rule are simple. So the rule is that this should be, let's say that this is a, just for your explanation, let's say this part is a, this part is b. So looking at this part a, the first digit should be a non-zero. So the first digit here, this first digit should be non-zero. Let me clear it out. And then we will introduce a decimal point here. So first digit should be non-zero, and then we will introduce the decimal point. So this is the rule here. And also the fact that in more mathematical language, a should be greater than equal to 1, but it should be less than 10. So mathematically we can write as that a should be greater than equal to 1, but it should be less than 10. So here, so this whole value should be greater than equal to 1, but it should be less than 10. In this case, for instance, let me change the color here. In this instance, I can write down 9.99, and this condition also will be correct. Why? Because it's still it's still less than 1. Oh no, I'm sorry, it is less than 10. So I can write 9.99 as long as I am under this condition, and that is that this part should be greater than equal to 1, but it should be less than 10. Or for the matter, the first rule I told you about, that the first digit should be a non-zero followed by a decimal point. So this was the scientific, in a more mathematical term. Let me just clear out this, the example that I showed you. And mathematically, in more mathematical sense of language, this is, yep, a uniform rectangle, quite rectangle. So and then we have the part b. So in case of part b, the most concerning thing it will be tens exponent or tens power. And the whole main thing depends on the exponent. So the exponent here, the exponent should be an integer. It doesn't matter it's positive or negative, but it should be an integer. It won't be it won't be a decimal point, decimal value, or in case of fraction, for example, like 1 by 2, we can introduce tens power 1 by 2, but it won't be correct for in this case for writing scientific notations. So the tens exponent must always be an integer. It shouldn't be a decimal form or a fraction, or a fractional form. Now, next question. Let's have some few examples here, and but before these examples, this is till now I've told you about how to check if whether the scientific notation is written correctly or not. So these are the points here, main points. Should I write? I think for your convenience, I think I should write first digit non-zero and then followed by decimal point. Please don't mind about my bad handwriting here. And then in a more mathematical sense, we have this one here. So this is also a point that this part, which is let's consider a should be greater than equal to 1, but it should be less than 10, and the exponent is integer. Exponent, or you can say power of 10 must be integer. So these are the points. These are the points for checking whether that numerical value is correctly written in scientific notation or not. But let's say if you have checked the numerical value and it's not written correctly in scientific notation, so how will you try to properly write it into scientific notation? Well, the first, I think they are more the more general rule for you. I think the proper approach, the first approach that you guys might take is, well, just convert first into that incorrectly written scientific notation into numerical value, and then properly convert that numerical value back to correctly written scientific notation. That approach is also true, but in this video I'll try to introduce to you a more general method, and using that general method you can convert numerical value to scientific notation, or convert the scientific notation back to its numerical form or decimal value. So this is our general method, and it might be confusing or complexing for you guys at first, but once you get the hang of it, it's really easy. So before trying to introduce the general method for this, let's say we have a value here. Let's say we have a random value. Let's say we have value 1000. We have random value. Just I'll try to explain the general method by first giving you the as a short explanation. So let's say we have value 1000. So how can I introduce tens power, tens exponent of 10, that it doesn't change the actual value, which is 1000? Well, we already know that tens power 0, tens exponent 0 is equal to 1. So we can introduce it here, 1000 multiplied by tens power 0, as it doesn't change the actual value, which is actually this one, the 10,000 here. I think I've changed the color here. So this is the actual value, and introducing tens exponent 0, as it won't change the actual value here. So now let's try to introduce the decimal point. So where do I introduce the decimal point in a way that it doesn't change the actual value? Well, we already know that through the I will introduce the decimal point into the rightmost side, so it won't change the actual value. So here we have 10,000 and I'm going to do the decimal point here. Multiply with 10 to the power 0. And actually the decimal point is always at default here, but we don't write it because writing it or not, it won't change the actual value here. So so we have written the decimal point here. So I'm gonna make it into the scientific notation, step by step. So hopefully you can pick up the pattern here. So what was the rule? I'll just follow the first one here. Um, the first two one, and and the last two are just purely mathematical. So you can also follow these two for your own convenience. So let's I think change the color here. So let's into the so we already know the first rule is sorry about it, that the first digit should be a non-zero followed by a decimal. So we have to move the decimal point to the left side. So let's do it step by step. So here we have, so here I have pushed the decimal point to the left side, and then we have point 0. We have 10 to the power 1, and again doing it, this will be a painful because I have to switch colors here. Let me just have this one here. Okay, again going shifting to the left, we have, and again shifting to the left. Here now we can see actually I only written 1 0 because because more zeros don't make any sense here, because it won't change the actual value, and we have 10 to the power 3. So actually here we can see first value, first digit is non-zero followed by a decimal point. So we have this in proper notation. Also the exponent of 10 is in integer. So as you can see, I've done it in sequence. I think you'll get the you have gotten the pattern here. So as I'm moving the decimal point to the left, you can see here that the exponent of 10 is increasing by 1. I'm moving the decimal point to the left by passing through one digit at a time, and you can also see that these that the exponent of 10 is also increasing by one value here. So uh, wait for a minute. I think I'll just take this whole and shift it to the left. Sorry. Okay, here. Okay. So you can now actually see that when I shift the decimal point to the left, the exponent of 10 is increases. So let's have another value. The same, this will be the same, but the exact opposite of it. So let's say we have the a value, random value 0.001. Let me just highlight it. So again, the same thing, introducing 10's power 0 so that it won't change the actual value. 0.001 times 10's power 0. So here we introduce the decimal point. Here we already have the decimal point. So according to the rule, first digit non-zero followed by a decimal point. So here, how will we achieve that? Well, the non-zero is actually on the right side, so we will shift the decimal point to the right. So again, doing this in a sequence manner, shifting. So we have 0.01 times 10's power minus 1. Again shifting. Again shifting the decimal. We have 0.01 multiplied by 10 is power minus 2. And again shifting to the right, the decimal, we have, now I can actually cross out the zeros because we know the decimal point will be on the right side. We have 1.0 multiplied by 10 power minus 3. So here we have the value correctly written in scientific notation, here and here. So you can actually see now, you can, I hope you have you have seen the pattern here. So while shifting the decimal to the right, as you can see that the power of the exponent of 10 is also is decreasing. Here we had 0, then we have minus 1, minus 2, minus 3, done in a sequence matter. Decimal point shifted to the right, passing one digit, and as a result minus 1 decreases, the power of 10 is decreasing, minus 1, minus 2, by amount of minus 1. So I think you have gotten the idea now. Let's have another color here. So the idea is that, as you have seen seen these examples, so we can conclude that, let me just first draw the arrows, then I will explain it to you guys. Okay, I think I'll just stick with the red color here. So with this thing, we are with this example to the right, to the left of mine, as you can see, as the decimal is going to the left, the power of 10, the exponent of 10 is actually increasing. Increase. While on the right side of this example, you can see as I move the decimal point to the right here, the exponent of 10 decreases. You may have the minus a negative sign, decrease. So this is the general rule for it. For when we are trying to play with the scientific notation, as I move the decimal point to the left, it will increase. The power of 10 will increase. When I go move the decimal point to the right, the power of 10 will decrease. So with that keeping in mind, let's have a few examples, shall we? um, what should I do? think I think I should introduce, I will have another page here. Um, okay, now here we will include some examples here. Let's have example here. We have, for example, here we have 86.76 and 10 power 4. Simple examples, just follow the general method that I told you. Here, left increase, right decrease. Oh, okay, I think I missed it. Wait a second. Okay, let's just change it to orange here. We have 86.76 times 10 power 4. So you can actually see that the value is not correctly written in scientific notation. We already know that this value is more than 10, when in fact it should be less than 10. So this is clearly an incorrect scientific notation. So how we gonna solve this problem? So solving this, I will move the decimal point to the left side. So while doing shifting the decimal point to the left, I already know that the power of 10 will increase. So then we will have, I move the decimal point one digit to the left side. So I will have plus 1 here. So the result will be 8.676 times 10's power 5. I already know 10's power 4 plus 1 equal to 10's power 5. Okay. So let's have another example, shall we? Let's have another example. 0.4979 times 10's power 8. Sorry. Mhm. 10's power 8. So here again, clearly not correctly written in scientific notation. It's just beyond 10. It's just in the thousands, and which in fact this part here should be less than 10. Let's shift the decimal point, shall we? Again, shifting to the left side. But how many digits are here? Let's say I'll count it from here. 1, 2, 3. Okay, we have 3 digits to shift to the left. We will shift the decimal point to the left, passing these 3 digits. So what will have the we will have the answer point 0.005497 times. So here we have 3 digits, right? We have passed 3 digits, so it's gonna be, as we know, or going to the left, increasing, so it's gonna be 8 plus 3. So 8 plus 3 is 11. So this is the proper for the scientific notation here. Again, let's have another example. This is the same one as this one. Let's have another example. 876.987 times 10's power 3. Again, same thing, a really huge value going to the left side, passing 1, 2, 3, 4, and 5 digits, passing 5 digits to the left, and we will have the value 1.00876,987 times 10's power. As you know, we already know, we crossed 5 digits, so 3 plus 5, 8. Now let's have on the right side, we have the examples here. Let's have 0.759 times 10's power 4. How we will solve this problem? We already know first digit should be non-zero followed by a decimal point. So clearly we have to move the decimal point to the right, just only one digit to the right. So here we will move the decimal point to the right here. We'll have the value, we have the answer 7.59. 7.59 times, so how much will be, as we know, we moved only one digit, so it's gonna be 4 minus 1. So 4 minus 1 is equal to 3. Now we have another example, and also reminded to you, might be hard for you guys at first, but as long as you practice, there will be a time that you'll do it with a piece of cake. It's gonna be easy for you guys. So have the value here times 10's power 2. Let's have check the values here. Okay, now here again we're gonna shift the decimal point to the right side here. So how many digits have I crossed? 1, 2, 3, 4, 5. 5 digits I've crossed, of 5 digits. So I'll have the value here 7.8326 multiplied by 10's power. So how will I deal with this? The power of, as I know, going to the right side, the power of 10 will decrease. So how much will it decrease? We will have, how many digits did I shift, did I passed, did I went through when going to the right side? Well, I have 1, 2, 3, 4, 5, 5 digits, so it's gonna be 2 minus 5. This will be 2 minus 5. So we already know algebra here. 2 minus 5 equal to it will be equal to minus 3. So that's how you do it. Another example, the same one here. 0.000457 times 10 power minus 3. Oh man, okay. Not minus 3, minus 5, I'm sorry. Now again, shifting the decimal point to the right side here. And how many digits did we got? 1, 2, 3, and 4. So we're gonna have the final value, final answer in scientific notation. We have 4.567 times 10's power. So what's it's gonna be? Already know, right side it's decreasing. How much it's decreasing? 4 digits minus 4. So what will be the exponent of 10? Minus 5 minus 4. So minus 5 minus 4 equal to minus 9. So we will have the minus 9 value here. So that's it. This is the part 3 of scientific notation, how to correct scientific notation, and how do you spot that numerical value is correctly written in scientific notation or not. And I introduced a general rule that will be more easier for you guys. And the next video will be doing arithmetic operations on the scientific notation. So that's why I wanted you to introduce to this general rule. So as long as you practice enough, you'll get this idea. So keep this in mind. Left, approaching left, then moving the decimal to the left, power will increase. Moving the decimal to the right, power will decrease. And also, let's for the convenience of this video, for for the sake of the next video, which will be about the arithmetic operations on scientific notations. Let's say we have this value here, 8 point. Let's have this. Let's have incorrectly written in scientific notation, 8.676 times 10's power 5. So let me ask, you might all be wondering that, okay, we can now, with this general method, I can shift decimal left, right, while trying to increase, decrease tens power. So my question is, can I go further beyond than these digits? Can I go more beyond? Can I move the decimal point more beyond where, for example, this is the last digit, I move the decimal point here. Can I go further? Can I take the decimal point further beyond to the left side? And the answer is yes, as long as you respect the power of the exponent of 10. So how do we do it? For example, here I want to, for the sake of the next video, it's already written in scientific notation, but let's say you want to go to the left side again. So let's take the decimal point here. We will have the value 0.8676 times 10's power. So what will be the 10's power? I moved only one digit to right, so it's gonna be plus 1, 10's power 6. Now let's say I want to go even further beyond. So we're gonna, for example, we already know it's gonna be 0. So moving past 0, we will have the value 0.08676. So again, 10 moved only one digit to the left, increase plus 1, 7. So that's how you can kind of tweak the scientific notation for your own needs. From when we are now, we're gonna talk in the next video, I'll talk about arithmetic operations. So for the sake of that video, I'm trying to explain it to you guys. Now let's have another one. 7.59 times 10's power 3. So this is this value here. Now let's say I want to go to this side actually. So how will I achieve that? Now we already know, going to the right side, power will decrease. So we will have the value 759 point times 10's So already know, jump 2 digit to the right, so minus 2, 3 minus 2 equal to 1. So here decimal point, I can just neglect it, or neglect it won't matter now. So let's say I want to go even further to the right side. So how will we achieve it? We already know that if I place 0 0, it won't matter because the value will remain the same. For example, this. Now let's say I'm going to the right side again. So here I have jumped to the right, shifted the decimal point 1 digit to the right, and then we will have the answer 759.0. So again, 1 digit shifted to the right, minus 1, 1 minus 1 equal to 10 power 0. Again, going to the right side again. So now we will have 75900 tens power. So what will be the tens exponent? We already know 1 digit shifted to the right. So 0 minus 1 equal to tens power minus 1. So this whole example is basically just trying to go to the extreme case, trying to bend the scientific notation according to your own needs. Why for your own needs? We will find out in the next video, with the part 4, for while doing the arithmetic operations for scientific for calculating scientific notations. So I hope this video is informative to you, and let me just highlight this. What should I do here? Let me just pick this up and move it here. Okay, so as long as you guys are following this method, it's not gonna be easy at first, but once you get the hang of it, this is their general method for literally doing any calculations in scientific notations. So this is the video. I really hope that you found this video informative. And again, before trying to make this video, I told myself that make it short as possible. And now looking at it, it's half an hour gone here, 30 minutes. So I'm really sorry for taking so much of your time. So I really hope it was worth your time. And really I really hope that you found this video informative and helpful. And make sure to like and subscribe to my channel, and also share these informative videos to other persons. And this is it, and I'll see you guys in the next video, which hopefully will be the part 4 of the scientific notation series, and that might be the doing arithmetic operations for scientific notations. So really thank you for watching this video, and I'll see you guys in the next video. Thank you and goodbye.